class. So this week we're covering chapter 13, quantitative data analysis. Now I'm going to try to just cover some of the things that you guys need to know for your final paper for this semester. Next semester, we're going to go more into details about the different statistical tests. So what type of statistical analysis is appropriate when you're analyzing your data? So it's important to know which analysis is appropriate before you can analyze your data. It's really appropriate to know which analysis you're going to use before you even create your questionnaire. That way, you can create your questionnaire in a way where you'll be able to run the statistical analysis that you actually need to run. So when thinking about what analysis is appropriate for the data that you have, there are things that you need to think about that actually affect the type of analysis you can use. So the type of analysis depends on different factors. It depends on the research question, the description of your variables, degree of relationship among your variables, and group differences. You also need to consider your level of measurement of both your independent and your dependent variables. You need to think about the number of independent and dependent variables you have. And you also need to consider the ability to satisfy different assumptions that are associated with those analyses. Knowing these factors allows the researchers to be able to select and use the appropriate methods for evaluating those outcomes and practice effectiveness. It also assesses how social welfare and economic policies can impact delivery of and access of those social services. Social workers need to be able to interpret the results from these analyses. There's two types of statistics. Descriptive statistics allows researchers to describe or summarize the data. Inferential statistics are used to estimate a parameter and to determine whether test results based on those samples can be generalized to the population. There are different statistics used to assess the degree of relationship among the variables. Pearson correlation, chi-square, multiple regression analysis, those assess the degree of relationship between the variables. Other statistics like independent t-test, analysis of variance, which is called ANOVA, and multiple analysis of variance, MANOVA, those are used to assess the significance of group differences. So this slide right here is really important. You really need to understand your level of measurement, and you really need to know what your level of measurement is so that you can determine what statistical test you can use. So when designing your survey, you want to consider level of measurement. That way you design your questions using a specific level of measurement so that you can later on be able to run the statistics that you want. So nominal variables or categorical variables, these are assigned a numerical value, but the value is not meaningful. So a variable, for example, like gender, male and female, right? Those are not numerical. So in order for you to be able to run statistics, you'll need to assign them a numerical value. However, the numerical value has no meaning. For example, if you're doing male and female and you need to run statistics on gender, you would assign a 1 for male and a 2 for female, or a 1 for male, 0 for female, however, whichever number you want to use. So the 1 means nothing, the 2 means nothing. You just have to assign a number so that you can run statistics. Or variables measured at the ordinal level are assigned numerical values that can be logically ranked. So with ordinal level variables, those numerical values actually have meaning. An ordinal level variable would be, for example, Likert scale. So how likely are you to pass this class? Very likely, not likely, very unlikely. Just kidding, guys. No, but seriously, the ordinal level variable would be like a Likert scale, right? And so those numerical values from, like, for example, strongly agree to strongly disagree, from a 1 to a 5, the 1 means something and the 5 means something. So if someone scores a 5 on that, it probably means that they're very likely to pass this class. If someone scores a 1, it means that they're very likely to not pass this class, right? Or very unlikely to pass this class. So that's a Likert scale. So the number or the numerical value actually has meaning. Intervals. So variables measured at the interval level have intervals between categories which are equal and they do not have a true zero value. So they actually have intervals and the intervals between them are equal. So variables at the racial level have all the characteristics of variables measured at the interval level, but in addition, they have a true zero value. So with the interval level measurement, intervals are equal and there's no true zero value. However, the racial level is interval level plus there is a zero value. So for example, if you actually got a zero score on something at the racial level, that means that that zero is true. There's zero. For example, if you ask how many children do you have, 0, 1, 2, 3, and someone selected 0, that means they have no kids. So the 0 is a true value. So going back to the slide I just talked about, the level of measurement, it's always best to try to measure your variables at the racial level. The racial level is the highest level of measurement. Therefore, you can always break it down. However, if you measure at the lowest level, which is nominal level, you can't go up. So for example, if you are looking at age and you say, how old are you? Okay, it's an open-ended question. You're allowing the participants to basically just type in their age. That would be racial level, okay? If you ask them, how old are you? And you give them categories, now you did ordinal level, okay? However, if you did that and you ask them how old they are and you give them categories, they're now at the ordinal level. So there's only certain statistics that you can run using ordinal level data. However, you could have asked that same question at the racial level and been able to run a statistics because you did racial level. So try to always use or collect your data at the racial level. And as you're analyzing your data, you can then decide to break things down into ordinal or interval level data, okay? Okay, so statistical analysis used to describe data is your descriptive statistics. So we're covering this semester because you're writing up data analysis section for your final paper. So that's just going to be like a short paragraph telling us what you're going to do, how you're going to analyze your data. You're definitely using descriptive statistics because you always describe your sample. So descriptive univariate analysis are used to describe or summarize data that is related to a specific variable of interest. This is conducted when researchers are interested in looking at the characteristics of a variable to determine if it meets the assumptions necessary to conduct analysis. There are three types: frequency distributions, measures of central tendency, and variability. So as you're writing up your data analysis part of your paper for the semester, you would include that, descriptive analysis or descriptive data analysis will be used to describe your sample. So Pearson's correlation is the most common correlation analysis conducted. Researchers conduct a correlation analysis when they are interested in examining the relationship between two variables. So Pearson's correlation is used to determine the association between an interval or ratio independent variable and an interval or ratio dependent variable. So the only way you can run a Pearson's correlation, is if both your independent and dependent variables are interval or ratio, okay? If one of your variables are nominal and the other is interval or ratio, you cannot run a Pearson's correlation. So the only way you can run a Pearson's correlation is if both your variables, you got two variables, and both of them are measured at either the interval or ratio level. The most important thing is to know when you can use the Pearson correlation, because this would go into your data analysis section for your final paper this semester. If you are planning on using a correlation, at least now you know when you can use it. So a chi-square test of independence is conducted when the researchers Examine the association between an independent variable where both are measured at the nominal level. So when you have two nominal level variables, you would use a chi-square. There are 4 assumptions that should be met if you're planning to use this. Let's see. So both variables should be measured at the nominal level. If data are to be displayed in a contingency table, then each cell must have a frequency of at least 5. So there needs to be at least 5 in each category. It should be random sampling and the assumptions of independence. Okay, so data should not be correlated. And obviously, if you violate the assumptions, then there are other fixes that you can use to still be able to use chi-square. But really, chi-square can be used as long as your variables are at the nominal level. All right, so multiple regression is another statistical test, and it is used or it's appropriate when there is more than one independent variable, which are nominal, ordinal, interval or ratio, and then one dependent variable, which is interval or ratio. So there's, for your multiple regression, your independent variable can be either nominal, ordinal, interval, or ratio. However, your dependent variable must be interval or ratio. Okay, so if both variables, your independent is measured at any level, and then your dependent variable is measured at the interval or ratio, you can run a multiple regression. Now, if your independent variable is at the interval level, however, your dependent variable is at the nominal level, then no, you cannot run a multiple regression. Okay? So clearly there are some assumptions that need to be met to be able to run that as well. We're not going to go into all of that this semester. We're going to focus on that next semester. Dummy coding, again, we will cover that next semester when we're dealing with data analysis. All right, the next test is t-test. There are 2 types, your independent and your dependent t-test. Both types are appropriate when your independent variable is nominal with 2 categories. That means, like, for example, if you have gender, male and female, and so that's nominal. And then your dependent variable is measured at the interval or ratio level. However, when you use either of these t-tests, they're dependent upon the type of samples that you have for your research design. So your samples will determine whether you're using an independent or a dependent t-test. The independent samples t-test is also what we call the 2 samples t-test, or an unpaired t-test, an unrelated t-test. This test determines if there's a statistical significant difference between the mean in 2 groups, where both the mean and the standard deviations are estimated from the data. These are appropriate when groups do not have the same participants. So post-test only designs with non-equivalent groups, or experimental research designs when 2 groups receive different interventions. Okay, so the independent samples t-test is used when your groups have different participants. They do not have the same participants. The dependent samples t-test is also called the paired t-test. It determines whether there is a statistical significant difference between the means of observations of the dependent variable, which was then assessed twice. So this one's appropriate when we have the same participants in both groups. Okay, so you still have 2 groups, but it's the same participants. So for example, with the independent samples t-test, we determined that you would be able to use gender. So male and female, clearly you have 2 groups, and each person would only fit in one group, right? Females can only be in the female group, male can only be in the male group. If you have a paired sample t-test or a dependent samples t-test, you still have 2 groups. However, the participants are in the same group, in both groups. So this would be like, for example, if you have a pre and post test, okay? Your groups would be pre-test group and the post-test group. But the same participants are in the pre-test group and the same participants are in the post-test group. All right, the other test is your analysis of variance, or your ANOVA. The analysis of variance is used when you have one independent variable which is nominal with 3 or more categories, and 1 dependent variable, which is interval or ratio level. So the purpose of the one-way analysis of variance, or the ANOVA, is to assess for differences between the means for 3 or more groups. So the difference between the ANOVA and the t-test is basically you have more than 2 groups. T-test is used when you have 2 groups. ANOVA is used when you have 3 or more groups. Okay, so ANOVA is basically just an extended version of the t-test. A t-test is used when you have 2 groups. ANOVA is used when you have more than 2 groups. If your independent variable is measured at the nominal level and has 3 categories or more, and your dependent variable is interval or ratio level, then you would use ANOVA. If your variables are measured at anything other than what I just said, then you would not be able to run an ANOVA. Okay, so the MANOVA, which is the multivariate analysis of variance, it is appropriate when you have 1 or more independent variables measured at a nominal level and 2 or more dependent variables on an interval or ratio level. So the MANOVA is an extension of the ANOVA. So ANOVA has 1 dependent variable, 1 independent variable. MANOVA has 2 or more dependent variables. So the purpose of the one-way MANOVA is to assess for differences between the means for 3 or more groups. The independent variable is measured on a nominal scale and has 3 categories, and the assumption, and again, there are 9 assumptions that should be met when using the statistical test. And if you read the chapter, you'll be able to determine what those assumptions are and what can be done if you violate those assumptions, how to fix it to still be able to use those tests, okay? So basically, those are the different tests that you can say that you will use in the data analysis section. So based on those tests and based on the level of measurement that you've decided to do on your survey, you should be able to tell, okay, what statistical test can I really do? I just wanted to give you a brief overview of the statistical tests and when you can use them. That way you can at least write up the data analysis section of the paper. We will go into more details about this chapter in 595. So we're going to cover this chapter all over again to make sure you review, but also to go into the very details of each statistical test and the assumptions and the violating those assumptions and how to correct it and things like that. That should be enough information for you guys to be able to at least write up the data analysis section of your final project plan, okay? Because that section is basically just telling us what statistical tests you plan on using and how you plan on analyzing your data. We covered every single statistical test that you can use for that section. So your descriptive statistics, and then it doesn't necessarily mean that you will use every single statistical test. You do use descriptives, so we always describe our sample, but it doesn't necessarily mean that you're going to use a MANOVA and an ANOVA and a t-test and a correlation. It does not necessarily mean that. It may mean that you're only going to use an ANOVA, or you might just do a t-test, or you might do a t-test and a correlation, or you may end up doing a correlation and an ANOVA, okay? It just depends on what your study is about. It just depends on your design. It depends on your measurement, especially basically your level. It basically boils down to your level of measurement, okay? That will basically decide what statistical test you can use. There you go. That brings us to the end of chapter 13.